know if someone needs to switch the display. Oh. All right, sorry everybody, apparently I have to drag this over. And it went away. Yep. Sorry, everybody. We'll figure this out in 1 second. I love, like, I've been doing computer-related work, whether IT or networking or now SRE for a long time, for almost 20 years now. And the fact that we can never get AV to work perfectly is always hilarious to me, right? It's both AV and faxes are the two things that I see brilliant rooms of engineers always struggle with. I guess we can go to, I don't even have a second monitor showing up. It's not even showing up. Sorry, everybody. I mean, I can probably do this without slides if people really want, but.
Again, I could do interpret advanced.
Right, yeah. All right. Close Chrome, open it again. Give me 1 second, let me find my presentation in Drive. We'll start from scratch and see if that does it. Try turning it off and back on again, right? I promise it's a fun talk once I get started. And luckily it's a little short, it's not quite, it doesn't quite fill the 40 minutes, so this should work out just fine.
How long have you been in Squarespace now?
Been at Squarespace for a little over a year.
Yeah. How big is the S3 team now?
S3 is about 50 people.
50?
Yeah, about 50. We have about 450 engineers total. Too high?
Yeah, if you go down some,
All right.
16. It should be up to 2. If you put it on scale, it should show us on. But there's a 2 tab. Is it option?
I don't know, so I'm going to be talking about SLIs and SLOs. Do people want to ask me questions ahead of time?
Does everybody know what an SLI is?
We're going to talk about service level indicators primarily, right? Service level indicators fuel SLOs, which you've probably heard a lot about recently. It's kind of a hot topic. SLOs, SLAs, service level agreements, service level objectives.
Alex, how did that concept come about at Google, right? Because like, I read about SLIs, SLAs, SLOs. I had to figure out what it all was myself, right? How did that even come about? Like, what was the, like, what are the 3 things A, and then how did that even come about?
So it's really funny because you will actually, that's the first part of my talk. Yeah.
Hey, there we are.
There's actually a very long history of service level agreements. Hey, perfect. Awesome. Thanks, everybody. Thank you for waiting. Sorry about that. Oh, and now my clicker stopped working. There we go. All right, so perfect prompts. Let's talk about a brief history of service level agreements. So a thing I didn't know until I started doing research for a previous version of this talk is just how old service level agreements actually are. Because telcos have been using them going back into the 80s and even the 70s, and that's probably not too surprising. This is just basically saying, yes, we will ensure that this amount of data reaches you in this amount of time. But going even further back, I found a bunch of bank documents going back in the 70s and even parts of the 60s, where banks are basically telling each other, here is our service level agreements about how quickly we will transfer funds to you in case those funds belong to you. But then I even found a UN document dating back to 1948. It's only a few years after the UN was even created that used the term. And we can even go further back than that. I found a job listing in Boston in 1926 that mentioned service level agreements. And what's really kind of neat about this is this actually applied to the humans. It said, if you are going to do this job, you have to agree to provide this level of service. Your service level agreement will be you're able to output this many punch cards per hour. And if we think about it even more, this concept goes way further back. As long as humans have been exchanging money for some kind of service, there's almost certainly been some kind of expectation for what that service should look like. But look, I'm not a historian, I'm a site reliability engineer. My name is Alex Hidalgo, and I think reliability is very important. So, to go back to service level agreements, you've probably realized that this kind of term is being used more and more. And here we have a graph showing a curve of how often this phrase is being used in recent times. This data is from the Google Ngram project, which is something that has consumed centuries of newspapers and magazines and books to determine exactly how often certain phrases were used. But even so, the Google Ngram project was stopped, and it only ever got data up to 2008. So even though we see this huge spike over the last 15 years, we can probably imagine this has spiked up even further in recent years. And why is this? It's because we have so many services now, right? You have platform as a service, you have infrastructure as a service, monitoring as a service, network as a service, database as a service. And that's ignoring our favorite, SaaS, which SaaS alone can stand for software as a service, or security as a service, or search as a service, or storage as a service, right? There's just so many services. And even if you're not using cloud-based services for all your needs, you probably have a microservice architecture, right? So you have services that talk to other services, that talk to other services, that depend on other services. This is one of the reasons I think we talk about service level agreements and service level objectives so much today. It's services all the way down. But how do we get here? Why do we now live in a world of so many services instead of monoliths? And it's two different things, really. It's the introduction of the concept of continuous integration and continuous delivery, and the concept of microservices themselves. So back in 2014, Martin Fowler wrote an amazing article called Microservices that really kind of talked about how you should use this. But actually, in 2013, he also wrote an article titled Continuous Delivery. So maybe that's where things got started. But actually, James Lewis gave a talk in 2012 talking about microservices, and I'm sorry I forgot, but Jez Humble and David Farley published the book, Continuous Delivery, which if you haven't read, you should. And that's back in 2010. Except John Alspaugh and Paul Hammond actually gave a talk in 2009 about how they were doing more than 10 deploys per day, which seems kind of like the same thing. And actually, if you go even further back in 2005, Peter Rogers delivered a talk talking about micro web services. The point is, it doesn't really matter how this got started. It was absolutely a confluence of people adopting microservices and people adopting quick releases and continuous delivery. And exactly how it got started doesn't really matter. So instead, let's tell a story. Let's talk about how this happens. How do you end up with too many services? And so let's imagine we have this startup, and they have this idea for an app. And it probably starts off on just one developer's laptop, and then they get some funding, so they have a little more money, so they make this a little more distributed, right? They make sure it can run on Cube or VMs and just make sure that it can hopefully scale up. And as things get more complicated, as they add more features, they realize they need a load balancer in front of this to ensure that things are being routed correctly to all these different instances they have. And they probably need a database, right? to hold things instead of storing everything locally, because that just doesn't really make sense over the long run. And then as this startup hires other developers, these developers are like, well, wait, we want to add new features. And since everything's microservices now, this new feature is a different microservice, right? And so new features added, and then another new feature is added, and this new feature also has to talk to the database, and then a few more features are added over here, and these are all just still just microservices, right? And then they realize that all these services down here, they all kind of, they're interrelated, so we need another proxy in front of that to ensure that everything's communicating properly. And we realize we probably need an inbound-outbound proxy as well to track these kind of requests. And then a few more features are added, and they all talk to each other as well. And then we realize that the database can't keep up, so we've got to make the database distributed as well, right? And people keep adding features, and they keep adding services, and services, and services. And you end up with this big tangled mess or these deep dependencies, right? It's not uncommon to see in a large-scale company 10, 15 layers deep from an outside request going all the way down. I mean, quick tangent. I remember once I used to work at Google, and I had a protobuf, and when I deserialized it, it ended up having more than 1,400 fields, because it had just been passed through service and service and service and kept being encapsulated over and over and over and over and over again. So you start to look at this mess, and you're like, how can we better understand it? So you add some logging, right? The most basic of telemetry. And logging's fine. It can tell you basically what a single binary is doing, but not much more than that. So like, all right, cool, we have logging now, but this is really complicated because we've got to aggregate it places, and that eats up a bunch of storage. And it's actually very difficult, right? Like at Squarespace, our single busiest service is our log aggregation stack, because every other service sends stuff to it. So you add monitoring, metrics, right? This is a little bit better, right? Whereas logging gives you insight into what a single binary is doing, metrics can often tell you what a service as a whole is doing. So this is better, but still you end up with so much data and so much telemetry. And this too takes up a ton of storage, and how do you aggregate it properly? And are you supposed to be sampling this, or are you supposed to be downsampling as time goes on? How long do you store these metrics? Are they useful for a week or a month or a quarter or a year? So you're like, okay, cool, the new stuff is tracing, right? So you also add distributed tracing to the story, and this is even better, right? Because logs tell you about a single binary, and metrics might tell you about a single service. But tracing can tell you about how these different services talk to each other. But still, all of a sudden, you have all this data. What do you do with it? So just yesterday, Ben Sigelman of Lightstep posted a brilliant blog. I added the slide last night, where he defines a new term that he thinks we should be using instead of distributed systems, and it's deep systems. And a quote from this blog post is, "Deep systems are architectures where the top and bottommost services are separated by 4 or more hops." And his basic premise, and there's actually some math, like in his blog post, is once you get to 4, things become very difficult, and you need to think about your service differently. And I totally agree. I never thought about applying a new term to this, but I've been thinking about this for a very long time. And I think there is a general solution. How do you make deep systems reliable? Well, I think you use something that I've coined the reliability stack. I'm not the first one to talk about it, but I've never heard a term to encompass it entirely. At the bottom of the stack, you have SLIs, or service level indicators. And a service level indicator is just some kind of metric. It's some amount of data that tells you if your service is doing what it's supposed to be doing. The best SLI is binary, right? Either yes, my service is doing what it's supposed to, or no, it's not. Because that allows you to generate a ratio, which we'll revisit in just one second. But the most important part about service level indicators is that they measure things from your user's perspective. It doesn't matter how reliable you think you are. It matters how reliable your users think you are. And SLIs inform SLOs, or service level objectives. As we just talked about, a good SLI is binary, so it's either good or bad. So if you just take your total good events over your total events, you end up with a percentage. And a service level objective is just simply the target percentage for what you want that to be. This is also where you can introduce thresholds, so you can start saying slightly more complicated things, like my 95th percentile will respond within 200 milliseconds, and my 99th percentile doesn't respond until 500 milliseconds, all that kind of stuff. But the main point here is that SLOs let you pick a target that isn't 100%. Because 100% is impossible, right? No one here runs a service that has operated exactly as expected for every single second of every single day of every year. And that's totally fine. Users actually don't need you to be perfect. They don't expect you to be perfect. If a web page sometimes takes 5 seconds to load, that's probably fine, as long as it doesn't always take 5 or 10 seconds to load, right? And finally, at the top of the stack, SLOs inform error budgets. And error budgets are pretty simple. They're just a way of measuring and talking about your SLO over time. It doesn't mean much if you're just saying, are we meeting our SLO now? Are we meeting our SLO now? Are we meeting our SLO now? What's much more important is to have a more holistic view. How have we performed in terms of our SLO over the last day, the last week, the last month, the last quarter, the last year? The other thing that I think is very important about error budgets is it gives you a more human way of describing things. So you can have an SLO target that says we're going to be reliable 99.9% of the time. But what does that actually mean? That doesn't mean much to humans. What an error budget gives you is you can say something like, if we're only going to be reliable 99.9% of the time, that implies we're not going to be reliable about 43 minutes every 30 days. It's just a more human, understandable way of saying the same thing. Now, we started to talk off about service level agreements, and they're just like service level objectives. They're generally a little more strict. I don't talk about them as much, because the biggest difference between an SLO and an SLA is an SLA generally means that there's a contract involved. It generally means that you owe your customers something if you don't meet it. You owe them money, you owe them some credit, something along those lines. But the concepts are all the same. But I want to focus today, the rest of my talk, about SLIs, service level indicators, because they're at the base of the stack, and without them, everything else goes crumbling and maybe catches on fire. So why do I think SLIs are so important? It's just a few simple reasons. One, SLIs measure reliability, right? And your service has one job. It's to be reliable for your users. And again, when I say reliability, I don't mean availability. I don't mean uptime. I don't mean I have 0 errors in my logs and my metrics say everything's fine. That's not what reliable means. Reliable is what your users say. Your service needs to do what your users need it to do. And that means your users define your reliability, not you, right? I don't care if everything looks perfect from your side of things. If your users are not happy, things aren't good, and they're not reliable. And when I say user here, it doesn't have to be a human. Not everyone works on a customer-facing product, right? I work at infrastructure, like Squarespace. My users are other services or engineers at my company. The point is just, I'm going to keep saying user, because that's a lot easier, but I really mean anything that depends on your service. And that's what a good SLI is, right? To build this stack, to use SLOs and error budgets correctly, you need good SLIs. And a good SLI is something that measures the reliability of your service from your user's perspective. So let's give a brief example of what this might look like. So we have an example web API here, right? We'll start real simple. It doesn't really matter what it does. It's some kind of request and response system, right? You send it some data, it does something, and it sends you some data back. So what are some things that users may care about? Well, is the service up? Well, like that makes sense. It's a good starting point. So here we have our user, and our user asks, is the service up? And yes, the service is running. We have 15 pods in Kubernetes that are all running, and they're not crash looping, and everything's fine, except the user can't actually reach it. So, all right, we go back to our list of things we care about. Is the service available? Because that's actually totally different than is the service up, right? So the user checks again, and the user says, can I reach the service? And the user can. This is awesome. The service is available, except it's incredibly slow, so slow. So now we got to add another thing to the list of things we care about. Is the service up? Is it available? And is it responsive? What does the latency look like? And our user checks again, and it's awesome. The service responds so quickly, except it's only returning errors. So we go back to our list again. Is the service up? Is it available? Is it responsive? Are we getting any good responses? Are we getting enough good responses? And the user checks again, and it's cool. We're only getting 200s. everything's fine. Oh, but the data format's incorrect. All right, so we go back to our list again. Is the service up? Is it available? Is it responsive? Are we getting good responses? Is the data format correct, right? If you're expecting JSON, you better not get a protobuf or a binary blob, right? So the user checks again, and everything goes through, and this is, okay, awesome. We're finally here. The service is up, it's available, it's responsive, it's not returning too many errors, and the data is formatted correctly. Oh, except it's yesterday's data and not today's. And we can do this all day, right? We can go through and add many more than just 6. But the point is, this is how you need to be thinking about how you need to measure your service. Is the service up? Is it available? Is it responsive? Are the responses correct? Is the data correct? And finally, yes, the user is finally happy. This means the user finally considers this service reliable. It's returning them data in the correct format, and it's the data they asked for, not just any data. So now we have this long list of 6 things, and it's so much stuff, right? There's a lot of stuff to measure. There's a lot of stuff to care about. And now we have a new problem. There are so many things to care about. If only we could measure many things by measuring only a few. Except there's a solution. Just measure many things by measuring only a few. Right? So we go back to our list, and let's start at the bottom here. And if you can make sure that you're getting fresh data, that implies that the data format's correct, which implies that you're getting good responses, not just errors, which implies that the service is both available and up, right? You're getting all that with one thing. Now, you might have to measure latency slightly differently. It all depends on your setup. I might concede that. But the point is, even so, you're measuring 2 things to capture 6 things. So what would an SLI for this example web API look like? It could be something as simple as requests to our API will result in responses that provide fresh data to clients within 200 milliseconds. And if this is what you're measuring, if this is your indicator, you're capturing everything else. You don't have to worry about having a separate check, is the service running or not, right? If you can't get correct data out of the service, you know it's not running. And here's how we can do the simple math, right? So you have the number of requests to our API that result in responses that provide fresh data to clients within 200 milliseconds, also known as good events, and you put that all over total events, that gives you a percentage. And that's how you can determine what your SLO target should be. But now you might be saying, all right, this is cool and all, but my service is a lot more complicated than just a single web API. That's fair. Let's talk about something a little bit more complicated. Let's pretend that you run an online retail website. I think it's something everyone can wrap their heads around, right? So you have the primary web app, right? The primary interface, like the site server, and it's probably distributed because let's say you're a really big retailer, and since it's distributed, you probably need a load balancer in front of it to make sure everything's talking to it, and you probably need some kind of service to make sure people can log in, right? If they have an account. And you need some kind of payment gateway because you're a retailer. You want to sell things. You got to talk to credit card companies. So you have another microservice over here. And there's probably a database somewhere to store credentials and all sorts of things like that. And maybe you have a shopping cart service, right? Something to ensure that people can add things to it before they check out. And we could add a million things again, right? But there's only so much room on the slide. And we'll add a cloud over here because that represents the internet, right? So what are some things we might care about in this situation? Well, let's talk about the login process, right? If users here have accounts, it's probably pretty important that they can log into them. So what are some things we could check to see if the user can log in and make sure things are working well? We could check, can the web app talk to the login server? And is it talking to the login service? And that's not bad, because that probably captures some amount of whether or not the login microservice can talk to the database, right? So you're covering a few things here. But what it doesn't cover is, are all users even making it through the load balancer, through the web apps, to the login microservice? And even if you can measure that, it's also not telling you, is a rendered page actually making it back to the user saying you are now logged in, right? So we could focus on the transactions between the login microservice and the database, but that's not going to give us any more data than that. And just looking at the load balancer of the web app, well, I mean, that's okay. Now we know that traffic's reaching the web app, but we still don't know if the login process is working. Because to have a good SLI, you need to look at your entire user journey. That's the only way that SLIs actually matter. You need to look at something like this. You need to look at When a user external to my network logs into my website by providing a valid username and password, is their traffic able to be routed across the internet, properly load balanced to one of our web apps, which is then routed to the login microservice, which is able to verify the credentials in this database, which then sends back the proper response, which causes the web app to render the correct page, which it sends back up through the load balancer, over the internet, to the user's browser. That's what you actually care about, because that's what your users actually care about. And this is a conference about multi-cloud, right? We can get much more complicated than just a single web app with 3 microservices and 1 database, right? This is our original diagram of 1 million microservices, all depending on each other. Deep systems, not just distributed. But what I tell you here is it doesn't matter. We don't have to go further. Because there are some things that are much more difficult at scale, especially if you're running multi-cloud. I don't care if they're 2 public clouds or 3 public clouds or 2 private clouds, right? When you're running large-scale distributed systems, a lot of things are more difficult. Stuff like global data consistency. This is a very difficult problem, right? Cross-cloud leader elections, especially when the technologies are different, right? The talk just before mine kind of touched on that. Like every cloud's gonna have a slightly different API and a slightly different setup and all that kind of stuff. So how do you know where you're actually running? And cache validation, I mean, this is tough even locally, much less when you are running at a global scale. And like paying for this is difficult, right? Like the more stuff you're running, it costs you more, both in finances and people. As you scale up, you need more people to do things for you. And people are actually the most difficult thing to manage. But my point here is, if you're able to follow the example we had for the single web API, you're able to follow the example we had for the retail website, it doesn't matter if you have 1,000 microservices. One thing is still simple: thinking from your user's perspective. That's all you gotta do. Put yourself in their shoes. Think about what they want. And so an SLI for this slightly more complicated website might read something like, clients external to our networks provide a valid username and password combination, get a page that reloads in a logged in state. This is what you should be measuring. And it can be difficult to figure out exactly what these things are. But there's a few ways that you can go about this. Conduct interviews, not surveys. People are terrible at surveys. They'll click 1, 5, 1, 5. They'll skip the freeform text entry field, right? But conduct interviews. If these are time-intensive interviews, compensate your users for it in some way. And this, again, this counts for any kind of user. I don't care if they're not paying customers. They might be other engineering teams. Sit down with them in a room. Ask them, what do you need my service to do, and what is it not doing for you today? But an even better step is if you have a product manager, if you have a product team, they'd probably look at this SLI and say, that's not an SLI, that's a user journey. They probably already have a document literally titled user journeys. And that's a place you can start. Your product probably already has a definition of what it's supposed to be doing. Use that. Talk to other people in your organization. You don't have to go this alone. Product teams, development teams, operations teams, they all need to be working in conjunction for this kind of system to work. Because everyone should be on board about caring what your users care about. There's nothing more important about your product. These are the kind of things you should care about. Can the user log in? Can the user buy something? Does search work? Is the shopping cart consistent? Things that I will admit you should measure, but you maybe shouldn't care about unless you're like actively responding to an incident. API uptime, error rates, database query latency. Sure, have metrics for those, store them somewhere. Allow your engineers to examine them if they have to, but they certainly shouldn't be getting paid for them. They should be getting paid for the user can't log in or the user can't check out. And this system, I think the first line in the introduction for the book that was just mentioned is going to be something along the lines of, this book is kind of about SLOs, but it's mostly about people. Because this kind of approach, that's what it puts first. And the way it puts users first is that proper SLIs, proper service level indicators, they focus on the user's needs, and they focus on what they need. It makes your engineers happier because they don't have to get paid about as much stuff, right? If a single pod goes down somewhere, who cares if everyone can still log in just fine, right? So suddenly, your engineers are receiving fewer pages, which makes them happier. And your product teams are happier because they're brought into the conversation, and they're often neglected, right? Product teams are often brought in to talk about, okay, well, here's the new feature, and this is the sprint we're going to add it to, and here's when we think we can ship it. But they're not often brought into the conversation about, are our users happy, and are we being reliable or not? So take time, develop meaningful SLIs, because you end up with happier users, happier engineers, happier product teams, and hopefully a happier you. Thanks.
We have 5 minutes. Are there any questions? Deeper learnings?
Hi, thanks for this. It was really informative. So you mentioned about not caring about like the query latency or not getting paged out about that, but isn't at times that a symptom of an end user problem that's about to happen, that if you have so many queries, latency of your microservices are starting to slow down in the end, it is going to come to a point where it starts impacting the user?
Yeah, absolutely, 100%, right. That's why I say you still should be measuring these things, and you still should have metrics for these things. This is a short and fun talk, and I can't get into everything, right? There's a reason there's going to be a whole book about this. It's actually very complicated. The best possible world is you have an error budget, and you are measuring that error budget. And what you actually page on is, are we burning through our error budget at a rate that we believe we cannot recover from before we violate our SLO, right? That's much more useful if you can get to that point, right? It is not non-trivial to get there. It's a lot of work. You probably have to write custom code. You're gonna have to set up some black box probing things and all that kind of stuff. But that's the kind of perfect end result. That all being said, one of the other reasons I present the reliability stack as SLIs and then SLOs and then error budgets is they can each provide you benefit in that order. Even if you don't get to formal SLO targets, or you don't get to the point where you're able to properly compute how much error budget you have left, if you are still taking the time to say, well, one of my metrics, one of my bits of telemetry should be, what do my users care about? Then that's great. Like, you've taken a step towards it. In the real world, in a non-perfect situation, sure, maybe you still have to have pages or open tickets. Like, it's the other thing. I think too often the industry relies on paging someone when it could just be a ticket someone looks at during work hours instead of like 4 a.m. on a Saturday. Yeah, absolutely. Maybe you still need to be alerting on that in some fashion. It's not easy to get all the way there. So yeah, my talk's a little bit idealized. It's a step-by-step process. It's very iterative, and it can take a long time to get there. But yeah, I would just simply say, you don't need to be alerting anyone on latency problems or error rates if you're encompassing that by measuring something more global.
Hey, so following the thought experiment, returning to the e-commerce site, I was saying, well, so pick the 2 of 6 or whatever, and that gets you the indicative, indicators. So for this one of the indicators was, or I guess the hypothetical indicator was, user external to network providing accurate username and password combo is able to log in. And so, to make sure I sort of get it, this sort of measurement points for incoming API requests or whatever might be page is able to make a successful request to the login service, and then the last transmission from server side to browser saying, here's your new page. Did that actually succeed?
Yes, yeah.
Is that fair to
I
say?
mean, a way you can do this internally is, this is where distributed tracing comes into play, right? Because you have parent span IDs. If you're using open tracing, soon to be open telemetry, right? Just the way it works. You have this concept of a parent span ID, so a single request that goes through your system, no matter how many services it talks to, you can tell it's all the same operation, right? So yeah, a way you could do it internally is, well, I have this request, I have this parent span ID, and it comes all the way back, and we ship it back out of the load balancer. So that's one way. Another, and this is more complicated, but I think is even more complete, actually set up some kind of black box prober running outside of your network. Right? There are a lot of very, very advanced scraping technologies now that can do that. That can actually, once a second, go to your website, try to log into it, click a button, go to your shopping cart, add an item to it, right? That's even better. Now that's a lot more work, so there are ways to kind of approximate it internally. For example, for our log ingestion pipeline at Squarespace, we actually just realized we can do simple division of incoming messages to our Kafka queue divided by the rate that Logstash is currently indexing things into Elasticsearch, and that gives us an approximate end-to-end latency. And in that case, we've determined this is good enough for our users. Our measurement has enough fidelity that when that number is low, our users are happy. When that number is high, they're not. So that's maybe the other point, is like, yeah, you can get very perfect and use distributed tracing to follow these IDs in and out. You can get very perfect by building some kind of black box prober that sits outside of your network that logs in, but also maybe you don't have to, right? Part of this is don't overextend yourself. Don't aim for perfect. You can't hit 100%. So if you're able to just use 2 or 3 metrics and kind of mush them together to figure out something that's approximate enough, just do that and spend your time doing other things. Cool. All right. Well, thanks, everybody.